and start talking about future essays and things.
I just write yes.
Hello, Jordan.
Hello, Jordan.
How are you today?
So far, no one's watching. So. Okay. Yes. That was the homework, wasn't it? So.
In together.
You got it the week before.
Yes, you did. Okay, so we're looking for the optimal value S star. Are you writing it? Which satisfies.
Not writing that.
That satisfies. Otherwise, it's not making sense if you're just making sense.
I love the fact that you refuse to move the projector.
I write really slowly now, just on purpose.
So do you remember the formula?
Actually, I think I've got it somewhere. Oh no, never mind. Wrong pal. Oh no, I got both. I do.
Can we not show for context why you're not writing?
You can do. I'm not writing because Callum took the visualizer.
I did not take the visualizer.
It's as simple as that. Absolutely nothing.
That's your
Hang on, that's too much. Yeah, move it a bit here. Move it so that it shows my finger. Oh, good.
I can't see what it is.
Projected your
Well, I can see what it is.
writing job.
Then maybe a bit down. But yeah. Okay, do you have that? F of S star, big F, equals to a fraction.
Yeah.
Yeah, make the line.
But that means I don't know how big the line needs to be.
Yeah, but don't put it down there.
Yeah.
Fraction. Line has to go level with the equal sign.
So then I'm moving the equal sign then.
So, but that has to be level
Absolutely.
with the Anyway, okay, so it's P minus C divided by P plus H.
P, what we're going?
Minus C, those little letters.
P plus H.
Yes. Now we should say what they are. Okay, so S star is the value that we're looking for. That is inside the how many total the optimal number of papers to buy. That's the S star. Uh, $120, this thing, that's the purchase cost, that's the little c. 180, that's how much we
Sell over.
is not in the formula. This 180 is the little p, that's the shortage cost. And p equals. Because otherwise it looks like p pound. Okay, and then the subholding cost is the h, so that is.
I'm going to try and squeeze it in.
What's really upsetting? 0.007 pounds.
So right, you're just plugging it into a formula. So, okay. So, and what is this capital F? Okay, so right, believe F dot dot dot. Cumulative distribution function of the uniform distribution.
My high school teacher, we did cumulative frequency with right come through. And it took him 2 months to realise what we were.
Okay, so F of X, it's capital F, equals, you have 3 options, 3 cases. it's 0 if what? Fill in. Okay, let's go on. The last one is 1 if and the middle one is a fraction. X minus 200 divided by 100. If. Okay, so when is it 0?
When it's less than 200.
When it is less than 200, well, it's
The uniform distribution.
if what is less than 200? No. So if what is less than 200?
The demand.
Oh, x. F of x.
It's the same thing.
It's not. Is less than 200? Is it not working? Oh, it's working all right. This? And this? Excellent. So now we're looking for S star, which the value of this function is given by its fraction. So you just work out this fraction. What is it? E minus C. Substitute. Helen, keep working.
Yep.
I want the value of the fraction with these B, C, and H values.
0.497. Wait, what?
Close.
P plus H.
So yeah, so you get 0.332. Now you want x such that this fraction is equal to this. So right, equals x minus 200. Now solving this, you get, rather instead of x, once you write s star, or 532, yeah, sounds like that. So that's the value of s star.
You said it was X.
No, that's not f of s star. It's s star. F of s star is 0.332. It's not equal to f of s star. This is s star.
F of S star.
F of s star is this.
I'm just having nothing good after the rest of the time.
He's got a scan it and put it online.
I'm just going to put it online.
They'll put that one online.
Would you like some Tipp-Ex?
No.
But that's weird. Is that really true?
No, it's not. I times by 1,000.
I can't be bothered with
There
that.
you go. I times by 1,000 as well. So it should be 233.2 or something like that. Is that right?
What have you done?
I times by 1,000 instead of 100 by accident.
Oh, yeah. Good job.
Which is the same thing that happened last year, as I can see in my notes. So actually it's 233. My apologies.
No wonder Neil's research.
No, I corrected it last time.
There we go.
Okay, that's the answer. Any questions?
Alan knows like that 532. It's not between 200 and 300.
No, that's what confused me. So I just came to believe it was one.
Maybe he's watching. So someone is watching. Okay. Good. No question.
He's got a scan this and put it on.
Yeah, this is there. It just makes it look scruffy, so we tidied it up a bit. Twice.
Okay.
John, pass me that.
No.
Okay. Anybody solved this before coming here?
Why did
Yes.
no.
Okay. No marks today.
Does it
Yeah.
count towards my grade?
What?
The marks that you're giving out?
Not what?
Pardon?
You have
Not yet.
-1 every time you get it right.
So it doesn't count. I am worried about actual close review.
That's a good question. Why do you fly till the book?
Because there's a percentage of
Of people that can't be bothered.
I forgot what your distribution is, but there's always like some percentage of people that miss it, so you might as well book it. And then they
Oh,
give you
for
a
people being
complimentary flight. No. Some people just don't turn up.
So is that the authoritative answer?
Yeah,
Because-
Brian told me in first year.
Because Brian told you.
Using stats, is it?
Sounds about right.
Brian is the authority, so. Needs to be.
So
What have you done?
typically, as many as 15% of the people don't attend. So if you only sold as many tickets as you have, you have empty planes. Well, half empty. Whatever.
But
Question two.
they still do it because you remember, was it Atlantic flights? Where they were trying to make them get off the plane and you punched the passenger.
Dragged them off. Well, it's
Yeah.
just that doctor or whatever it was.
It was a different thing. They messed up the boarding process because obviously they should know that they can't let everybody board. Okay. Question two. Then if you just turn up at the station and say, I'm going to London, £460, please, thank you very much.
16 to 25 rail car actually.
Oh, so it's only 380. So why is that? You don't know?
Because they know people are desperate and they'll pay whatever they want.
Oh, kind of, yeah. So that's the idea. That's based on the idea that, I suppose, that
There's more capacity.
different people in different circumstances are willing to pay a different price for the same thing.
That's like the transfers going on. It's the same journey for a different price now.
So, for example, have you ever been to a bazaar in like North Africa or some of these Arab places?
When are we ever going to leave the country?
Oh, good go. I mean, the tickets are so cheap. To go. If you book in advance, the tickets are so cheap to go to these
Have you
places.
heard about that student who lives in Poland and just gets a flight to London every time he's got you? It's cheaper than Warsaw to get a flight to London.
Okay. Anyway, so yeah, let's concentrate. Yeah, so in bazaars, there's this kind of bargaining where
Oh yeah.
they start with different prices and then they somehow
Like
converge
looking-
to something. Do you know about that sort of
Yeah,
concept?
it happens outside MEN every weekend.
No? Is that something you've seen before in films or something? Or in, no? Okay. So yeah, so there's like the shopkeeper will say, oh, you can have it and it costs £500, and it's like, nah, never. So it's like, it's more like 20. I'm like, or 20, forget it, and then they start, and then they agree in the end on some price. And that price they agree can be different depending on who's buying. So there's a concept that you don't get a fixed price like you get here.
I was able to buy one of those massive Eiffel Towers. They were like supposed to be €30, about 5.
Yeah, there you go. It's just a question of asking. Okay, so so this is because people are willing to pay. Or different people. And so if you set the price low, then you're missing out on the money that you could earn from the people who are willing to pay more. If you set the price high, then you don't sell enough. And the goal is to try and make people pay different prices somehow. So this is these are two basic examples of the revenue management kind of thing that is going on in the world. This is a typo that I hate. I don't understand why I put it on my slide, even though it's something that I really don't tolerate.
We went back in time, obviously.
And lead was not a poisonous substance.
Oh, lead with an A is a poisonous substance. Okay, so
Yeah, makes more sense.
Red and read.
look it up on Wikipedia, the 1978 Air Line Deregulation Act in the United States.
Okay.
Not now.
On the project.
Basically, it was before then. The situation was such that there were a couple of airlines. They had their routes. The prices were cheap. Everything was subsidized by the government. You turned up, you bought a ticket for the next flight, and it cost the same as booking in advance, and there was nothing like that. And more or less, it was a system of monopolies. So for every pair of cities, there was just one airline that was offering flights for those two cities and things like that. That was I'm talking about the internal, so-called national market in the US, because people fly a lot across the US. And then in 1978, they introduced this deregulation, so the kind of system that you know much better than the previous one, where there are all these EasyJets and Ryanairs and similar companies, and they offer very cheap flights. And so then the major airlines obviously were losing money, so they started doing these things.
You heard about the Ryanair scandal? You have to get partners involved and just have 2 bags out.
Well, that's all right.
Don't know right now.
So today we'll look at, so that there are these two basic models. We'll look at those two things in revenue management that we've been talking about on the previous slide. Discount fares, how to offer discount fares. And the second one is overbooking. So today we'll do the first one, and next week we'll do the second one. I've lost my notes. I don't know what I wanted to say. yeah, so when you're offering, okay, so the model is the following. Kind of a very simplified model that for some time before the flight, you're selling cheap tickets, all for the same price. So we're looking just at two different prices in this simple thing, because otherwise it gets too complicated. So as an introduction, it's quite good. And for some time before departure, you're selling cheap tickets, and then you think that after that time, the business people are starting to book tickets who are not paying out of their own pocket, so they're willing to pay more because their company is paying. And now the risk is, if you sell too many cheap tickets, then some of the business customers will just have to go away because you won't have enough capacity. But if you sell too few of those cheap tickets, then not enough business people are going to turn up and want the ticket, so you might end up with a plane that's not full. And that's it. Those are risk of overbooking, so that doesn't really go. So actually for both models, when you look at it, you've got these three things that have to be done. Modeling what the customers, guessing what the customers are going to do. So there's a lot of statistics in there. And now all the big data things, obviously. So data analytics. So we're not doing that now.
Yeah, I mean, because there's no space. Oh.
OR is we're analyzing the strategies to you know, and looking at what to do, and then of course you have to implement it in practice, and that's, you need some kind of IT system to do that, because in the volumes that of plane tickets that are sold these days, you couldn't just do it by hand. Project is irrelevant at the moment. Thank you. Okay. So now look at the thing that we're doing today. These are the assumptions. Kind of silly. No, I mean, they're not silly. The first one is. Okay, so you have inventory known. That means you know how many you're willing to sell. Is that clear? Well, that's a different question. No, let's say we know that there's a certain number of tickets or room bookings for a hotel, the same model, or something like that, and you know how much it is. That's an assumption. And we're only assuming that there are two kinds of passengers. Class 2 are the leisure travelers, let's say. So the those are interested they're interested in the cheap tickets. And then those are the business customers. This is not dealing with the kind of business class, economy class distinction. That's different. Customers for the same type of seats. It's not different. Travel class is just a different price category, right? So when you can say something like 2 weeks before the flight, we'll stop selling class 2, but we can stop selling class 2 even before then, if we've sold enough of them. And now the question is to determine how much you should sell of the class 2 before you stop selling them. Okay, or how much you should reserve for the more expensive customers. Makes sense? And then an assumption on the demand or for the expensive tickets is that we don't know the demand exactly, but we know its probability distribution. So it's a random variable, and we're assuming that we know what the probability distribution of that is. Okay, so okay, so what is the model? The parameters are what we know is we're assuming that we know the size of inventory or the number of tickets that we want to sell. We know the two prices, so P1 and P2 is the price paid by the respective two classes of passengers for the same ticket. And then we know the demand. The demand by class 2 is irrelevant. Okay, it's kind of okay. No, it's not negligible, but it's not. We don't need to know it in order to determine how much we should set aside for the class 1, because that just doesn't depend on what the class 2 are doing. So this is a random variable. And I think again we'll have a cumulative distributive function F. And now the decision is how many tickets should be reserved for class 1. It's a seal. Doesn't look like a seal, does it? Okay. So the way we'll do it is, I'll call it marginal, or it's called marginal analysis. And the question is, when L minus X cheap tickets have been sold, or class 2, and the customer arrives, arrives, and it's before the deadline, 2 weeks or whatever we've said. Should we sell or not? Okay, and if the answer is yes, then our optimal solution is larger than X and not smaller than X. Okay, so L minus X cheap tickets have been sold, which means that kind of X tickets still remain for class 1, potentially. And in this situation, the question is, should we sell or not? And that will determine the number of tickets that are reserved, because if we should sell, then the number that is reserved should be less than this X, obviously, and if we shouldn't sell in this situation, then it's at least this X. I think that's clear. So, well, I hope it's clear. Well, maybe it's not. What's wrong? Anything wrong? No? Oh, okay. Okay, so how much do we make from this? So what is the what's called incremental revenue? I'm not defining incremental revenue. It will be clear when I say what it is. So if we sell the ticket, then we're earning P2 because we've sold it for P2. Okay, from this decision. That seems clear. I hope it is. Now the problem is, what happens if we don't sell? I'll do it the common way, the 2 arrows. So if we don't sell this particular seat for the cheap price, there are 2 possibilities. Either there will be enough class 1 customers who will buy this particular seat, or there won't be. And if there won't be enough, if there are not enough people who want it at the more expensive price, then we're earning nothing. Yeah, so if the demand, the random variable, turns out to be, well, no more than X minus 1, then this seed number X is not going to get sold. And then we won't earn anything from it. Okay? But if, and we will earn the first price if the demand, the random variable, is at least X. Okay? So we're looking at a situation where there are the top X seats are still left for class 1, and we're looking at the X seat, whether to sell it cheap or not. And if we sell it cheap, we earn this much. If we don't sell it cheap, then we're either earning nothing if the demand is going to be small, or we're earning a bit more if the demand is going to be large enough. Okay, that's the idea. And so what we're looking for is kind of okay. So we should sell if what? If the gain from selling it is larger than the expected revenue in this case. And so the expected revenue in this case is P1 times the probability that the demand is going to be larger than X. Okay. Do you agree?
It's just like you said, larger than, but that's larger than equal.
What I wrote is larger.
Oh,
What? P2 is larger than the probability that the is larger than or equal to x times the gain plus the probability that d is no more than x minus 1 times 0, which is 0. So that would be the expected revenue in ohms, of course, but I'm not writing 0 times something because that's 0. Okay, so this is really what we're looking for, is that the optimal x when we should stop. Okay, so of course, as x is increasing, this probability is decreasing. Yeah. So this, you can see this is a function of x, and x with increasing x, this probability is decreasing. So at some point, as x is increasing, no, I should be doing it the other way around, right? As x is decreasing, so what we still have left in store for the class 1 customers, as it's going down, this probability is going up. And at some point, this product is going to be larger than that. And the first time this is larger than that, this is when we've sold too much. Okay, so we're looking for the last x, and we're going down, for which this is still like that. Okay, so we're looking for the minimum value of x that still satisfies this inequality, I'll call it star. Don't have any space on this page thing. No. I'll start a new page. Is everybody all right with this? Can I go on? Oh my goodness, we're running out of time. No. Okay, so now if L is large, so this is kind of a of course the demand is a discrete random variable. Well, we'll do the usual trick. We'll just because if L is large enough, we can just approximate D with what? With a continuous random variable. So okay, so if you remember this star, that was when P2 was greater than P1 times the probability that D is, I'll just repeat it so that we can all see it. So in fact, what we're looking for when you make it continuous, we want X star, the optimal solution, which satisfies that P2 is exactly equal to P1 times the probability that D is greater than or equal to X, which is P1 times the cumulative distributive function. Oh no, 1 minus, apologies. So 1 minus the f of x, x star. Okay. She's unhappy again. Quite easy to make you happy, but it's also quite easy to make you unhappy. Okay. that's what we're looking for. And when we solve this for f of x star, and we get that it must be 1 minus p2 divided by p1. And knowing the cumulative distribution function from this, you can get the x star. But there's no common formula because it depends on the distribution of the demand. So then the policy is if the number of seats remaining for class 1 is no more than its x star, don't sell. And if it is greater than this x star, then sell. Those x star rounded down is the number of seats you want to reserve for those customers. And now there's an example. Quite a long text. Okay, any questions about this? Shall we do the example quickly? There's another one in the homework, so keep the formula there. So in the example, it's quite hard to read, which you have in the handout. It's quite hard to read quickly, perhaps, but there are 200 seats altogether, and it says that the class 1 price is £1,000. Class 2 price is £200, and there's a lot of gibberish as well. Yeah, but that's the important thing. So it says that we're looking for x star that satisfies f of x star is 1 minus 200 divided by 1,000, which is 0.8, is it? And it's also assuming that the demand has the normal distribution, and the mean is 60 and standard deviation is 20. Now I've got this table here somewhere. Can you see the table?
This is P building.
That's the table.
Can be found on Moodle.
So when you look at 0.8, oh, is there 0.n in this table? No. So you have to look at 0.2 in that case because it's 1 minus. So 0.2 says 0.8416.
Mm-hmm.
Okay, so 8416. think you have to multiply 8416 by 20 and then add 60 or something like that. Is that right? So I want the probability that my demand is not going to exceed a certain number to be 0.8. So I want the probability that it is going to exceed it to be 0.2, and that's exactly what we found. So for 0.2, we found 0.8416, and so X star is going to be this 0.8416 times the actual sigma plus the actual mu, which apparently is 76.84. And we're told to round down, so we should keep 76 seats for class 1. Yeah, why don't we do 1 minus where? Oh, here. Yeah, because the table, it's not like 5 in the level. So looking at this probability,
That's because all the mu tables are back to front.
Right.
You have to do the same in finance, you have to do 1 minus the variables as well.
no, it's not 1 minus.
But that's but with your negative 1 minus effectively.
So it's not 1 minus, it's 0 minus.
Yeah. Yours is the same variable.
That's right. Anyway, it's the yes. So if it's more than 1/2, then definitely that value will be positive. I mean, the meaning of this whole thing is really, when you look at it, it says that you want the probability that you will satisfy everyone to be 80%. Okay, all the class 1 customers. That's what this formula told you. And then you just work out what the right number is that gives you that probability. So it's correct. Do you want me to spend more time on this? Or are you okay?
I think I'll go once I don't have a migraine, but I don't keep out to
Okay. All right then. That's it for now. Yes. There's a homework problem. Any questions at all? Good.
extra credit.